Okay, the next series is what we call it, the Balmer series. Okay, next we have Balmer series. Now we can say that this series, if we observe this series, then this series lies in the visible region. Okay, and for which the emission of wavelength occur when electron jump from outer orbit or higher orbit to second orbit. Like here, I will use the same diagram here. What will happen? This is the second orbit, okay, because n value is 2, so this is the second orbit. When electron jump from higher orbit to the second orbit, we get a series which is called Balmer series. This is called Balmer series. Now, for Balmer series, we have, for Balmer series, we have the general formula is given by this one. 1 over lambda is r times 1 over nf square minus 1 over ni square. Now for Balmer series, the principal quantum number of final state, which is this one, the final state is this one. For this, the principal quantum number is 2. So nf is equal to 2. And electrons come from n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 5, n is equal to 6, and so on. So we have the initial principal quantum number is 3, 4, 5, and so on. So for Balmer series, we have this one. Okay. The principal quantum number of the final state is nf, which is 2, because electron jumps from higher orbit to n is equal to 2 orbit, a shell, a L shell, and higher orbits are 3, 4, 5, and so on. So we have the Balmer's the general formula, which is 1 over lambda, which is equal to r times 1 over nf square minus 1 over ni square. Now convert to 1 over lambda, which is equal to r times 1 over 2 square minus 1 over ni square, where ni is 3, 4, and so on. This is the Balmer series. Next we have another series which is called Paschen series. Okay. Now this series lies in infrared region. Okay, infrared region, like the color of or the wavelength of the light or the spectrum or the radiation is in the infrared region. Now this series, for this series, the wavelength occur when electrons jump from higher orbit to third orbit. Here again we have the third orbit is this one. Okay, Now when electron jump from higher orbit, like for n is equal to 4 to third, n is equal to 5 to n is equal to third, n is equal to 6 to n is equal to third, and so on, we get Paschen series. This is the Paschen series. So here we see that we have the final principal quantum number of the final state is NF is 3, and the principal quantum number of the initial states are Ni, which is either 4 or 5 or 6 and so on. So we have 4, 5, 6 and so on. So this equation now, the Paschen series become like this: 1 over lambda, which is equal to R times 1 over NF is now 3 square minus 1 over Ni square, where Ni is 4, 5 and so on. This is the Paschen series. Next we have bracket series. Now this is the fourth series of the hydrogenate spectrum, in which this series comes when electrons jump from higher orbit or outer orbit to fourth orbit. This is the fourth orbit, okay. Like here we have the fourth orbit is this one, okay. N is equal to the n orbit, for which n is equal to 4. If electron jumps from higher orbit, like from here to this, or from here to this, or from here to this, or from here to this, we get this series. This series is called bracket series. This is called bracket series. Now here for this series we have NF value is now NF value is 4 here, okay, and Ni value is either 5 or 6 or so on. So this formula now modifies to 1 over lambda is equal to R times 1 over 4 square, okay, minus 1 over Ni square. This is the bracket series. And we have the last series, which is called P-Fund series. The last series is called P-Fund series. This series comes, this is also in the infrared region, okay. This lies in the infrared region, and this comes from the transition of electron from higher orbit to fifth orbit. Like if electrons, this is the fifth orbit, okay. This is the fifth orbit. If electrons jump from higher orbit, these are the higher orbit, to fifth orbit, we get a series which is called P-Fund series. Now this is in the infrared region, and also we have the NF value is 5, because N value is 5 here, and we have the Ni value is what, 6, 7 and so on. So the general formula for this series is 1 over lambda, which is equal to R times 1 over 5 square minus 1 over Ni square, and we have Ni is equal to 6, 7 and so on. So these are the 5 series we discussed so far. So here I will plot the diagram again. Like we have the energy levels here. So this is the first energy level are the K shell, and this is the second energy level are the L shell, this is the third energy level आधा M shell. This is the fourth energy level आधा N shell. This is the fifth energy level आधा O shell, and these are the higher energy level. So as we move away from the nucleus, these energy levels, they get closer to each other, and at infinite distance this energy level will overlap with each other. So the difference between these two energy levels is greater as compared to this one. So here I just plot it in a wrong way, but basically this difference will be bigger than this one. So this one will be bigger than this one will be bigger than this one, and finally we have this pattern here. Okay, now these are the value of principal quantum number. Here we have n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, and so on. And we have n is equal to 6, and so on. Now when electrons jump from higher orbit to first orbit, like electron jump from this orbit to this, this to this, this to this, or this to this, or this to this, we get a series which is called Balmer series. And this series lies in the ultraviolet region, okay, for which we have the NF value is 1, and I value is 2, 3, and so on. Next we have the transition of electron. When electron make a transition from higher orbit to second orbit, we get a series which is called Balmer series. Okay, this series also lies in the visible region. And for this series we have the NF value is 2, and I value is 3, 4, 5, and so on. Now when electron jumps from higher orbit to the third orbit, this is third orbit, jump from higher orbit to the third orbit, we get a series which is called Paschen series. And this series lies in the infrared region, okay, for which NF value is 3, and I value is 4, 5, and so on. And when electron jumps from higher orbit to fourth orbit, okay, we get a series which is called Beckett series. This also lies in the infrared region, and for this series we have NF value is 4, and I value is 5, 6, and so on. And finally we have the last series which is called P-Fund series, which comes from the transition of electron from higher orbit to the fifth orbit. This is P-Fund series. This also lies in the infrared region, for which NF value is 5, and I value is 6, 7, and so on. So this is all about spectrum of hydrogen atom or hydrogen spectrum. In the next video I will move towards what we call it, the new topic which is called hydrogen atom according to Bohr theory. So this is all about spectrum of hydrogen atom. Thank you.